Good afternoon. This is Dr. John Bennett from sunny Miami. We have another episode in the MedGadget Hangouts exploring areas of medical technology and medical devices. Tonight we have the pleasure of having Dr. Roger Smith. He's the head of the Robotics Center, or not the Surgical Training Center, in the Nicholson Center in Celebration, Florida, which is just south of Orlando. Also, we're joined by Gene Ostrovsky, the head editor of MedGadget. First, I'll say hi to Gene. Hello, Gene.
Hey guys, thanks for being here, Roger.
Yeah, thanks for coming. Gene's in cold Michigan, 20 degrees. It never gets that way in Orlando or Miami. Okay, Dr. Smith, welcome.
Well, thank you.
So yeah, we'll just start with a couple of questions. When did the first Nicholson Center? When was it first conceived? About, obviously it took some planning. So
right. So the Nicholson Center actually started under another name about 13 years ago. The hospital realized that there was a demand by surgeons for a place where they could go to learn new skills every year. And for them, skills didn't mean sitting in a classroom. It meant putting their hands on real equipment and us giving them all of the support that they would have in a real operating room with something similar to a real patient, usually some kind of animal tissue, beef tongues, chicken breasts, the offal that you would get from a butcher shop. And we started it in a very humble setting inside the hospital. And we spent about 10 years doing it in borrowed conference rooms and a small laboratory before the hospital felt like we had demonstrated that we were a sustainable entity and we could keep this going for a long time. So they built us a beautiful facility, which you can see one of the rooms of behind me. Beautiful 54,000 square foot facility that cost several $1,000,000 where we could do this training full time. So now we have one building that's kind of like a graduate school for physicians. And we have over 10,000 physicians that come through here every year to learn something new about a procedure in their field, maybe a brand new instrument's coming out, sometimes some kind of tissue sealer, and they take a class on that. And as surgeons, they're required to take at least 40 hours of this kind of training every year, and we're able to offer a different kind of course almost every day here at the Nicholson Center.
Very good. I'm sure we both have a lot of questions, but we'll watch your presentation first and then ask them later. Does that sound good?
Sure, that'd be super.
Okay.
I need to get some technical help. We'll switch to the presentation here.
Okay. Okay.
Okay.
There we go.
So one of the biggest fields that has been growing over the last few years is robotic surgery. And here at the Nicholson Center, we were literally bringing in thousands of surgeons every year who were very competent and proficient open surgeons or laparoscopic surgeons, and they were trying to add robotic surgery to their portfolio. And the number of robotic surgeons was growing every year, and we were right at the heart of creating the training for those robotic surgeons. But the training that existed wasn't really standardized across the nation. So we launched an initiative to try and create a standardized robotic surgical training so that every surgeon that was moving from some other practice into robotics would receive the same kind of training and also would be tested to the same level of proficiency. So this presentation kind of runs over the program that we led to try to make that happen. So if you look at Intuitive Surgical's materials, they keep track of the number of robotic surgeons that are done with the Da Vinci robot every year. And currently there are around 570,000 procedures that were performed in 2014, and there'll be more in 2015. So there's over 500,000 people that are having a procedure done, usually in urology or gynecology, a little bit in general surgery and ENT and a couple in thoracic. But every year over 500,000 people are having these surgeries done. So that's a lot of surgeons that have to be trained and proficient in order to do these surgeries. And so this field was growing, but the curriculum that surgeons went through was of one of two kinds. One, it was provided by the vendor of the robotic surgical device. And they have a wonderful training program, but they teach it themselves as part of their corporate sales process for the device. And even though the material is outstanding, the fact that the training comes from the vendor is really not what the surgical field likes to see. They like to see a curriculum that's developed by the best surgeons in the field and that's agreed upon by those surgeons and that speaks the voice of the surgeon, not of the company making the device. Then the second thing you had was a few surgeons were running small programs where they would teach that kind of a curriculum in their own facility, but it was different at every facility. So we had some really great collaborators in Pennsylvania, in Dallas, in Virginia, in California, that were all creating these kinds of classes, but they were all different. And so what we wanted to do was bring all of these expert trainers together and create a standardized curriculum that anybody could teach anywhere, and that all of the surgeons that were the leaders in this field felt like was an acceptable level of knowledge and skills for the surgeon that's coming up behind them, and that also had some kind of a testing mechanism where you measured the level of proficiency that the people achieved before they went back to their hospitals. So we started up that project really in 2011, and we've spent about 4 years driving that project. We were lucky enough to have 2 different grants, one from industry and one from the U.S. government, to pay for the expenses of this over a 3 or 4 year period. We brought in the best surgeons, the best robotic surgeons in the world from across the United States, Canada, a number came from Europe, several from Asia. We had some Ireland, several came from Brazil. So we tried to reach out and get a broad sampling of the leading robotic surgeons in the world. We also got some from the Department of Defense and the Veterans Health Administration. And we spent this time extracting from them what they felt like were the essential knowledge components and skill components that a robotic surgeon should master before they move on to practicing on humans. And among them, or between them, they came up with 25 outcome measures, which is a way of saying skills or knowledge components that the surgeon should be able to master before they pass this course. And the people that came up with those 25 outcome measures represented 14 different specialty societies that spoke on behalf of urology, gynecology, general surgery, ENT surgery, thoracic surgery, some specialties in laparoscopy, even a couple of plastic surgeons and orthopedic surgeons who don't really use the robot, but were exploring whether they could or not. So we developed this curriculum, and part of it is cognitive, where you sit down and you study materials. We hosted all of that material online on a website, and we made it freely available to anybody in the world. That website is frsurgery.org, which we didn't put on the slide, but anybody could go there and request an account and go through the material. Then we created a psychomotor component where you put a device under the robot, which I'll show you later, and they actually show you the skills they have with their own hands. And then we have components that teach them how to interoperate with their OR team around a robot and be effective communicators with everybody that's in the room. So we created that material, but in true scientific fashion, just because the best surgeons in the world say this is the right material for training somebody, that's not scientific proof that it works. So we launched a multi-site research program where several sites went through the curriculum and trained subjects in a research experiment and measured their performance and their improvement through the curriculum to see if getting through the curriculum really did raise their skills from where they were when they came in to where they thought they should pass a test on this material. So this is the psychomotor skills device we developed. There was a subcommittee among those 60 surgeons that sat down and said, what skills do we really have to see them demonstrate with their hands? And we want those skills to be all integrated into a single device so that each skill is not a separate product which you would buy from a catalog somewhere, but they all are welded together. And we want to see that those skills are distributed in 3 dimensions. Most of the surgical skill tools are very 2-dimensional. They're very flat. And so you're either operating on a surface that's laying down on the table or standing up like a wall. And so they came up with this bowl design, or what we call the FRS Dome. And through a number of engineering iterations and tests with the surgeons, this thing evolved and evolved and evolved until it's the product you see on the screen. And we were able to produce it and then make it available so people could purchase it. The online curriculum that I mentioned before is completely free. We would make this free if materials were free, but they're not. So because we have to pay to have this made, we have to charge people who want to get one for themselves. And then we also worked with a number of simulator companies in this field. The Da Vinci robot is a very expensive piece of equipment. It costs about $1.5 to $2 million for an individual robot, and that makes it a very expensive thing to train with. It's very much like offering a pilot an airplane to train on. You can't just hand every pilot his own 777 to go out and fly until he gets good at it. You really need to have simulators sitting around that he can practice on until he's ready to test out with the real aircraft. And so in robotic surgery, that same model applies. There are 3 different companies that offer simulators of the Da Vinci robot, and you can buy a simulator to practice on for about $85,000. Well, we worked with all 3 of those companies, and we got all of the exercises from that dome object converted into virtual exercises inside their simulator. So at the same time that the curriculum was available and this physical dome was available, you could also get an update to your simulator if you owned one, and have all those same exercises inside of your simulator to practice with. The physical dome is really the best tool to work with, but since it's physical, there are some parts that you cut up and tear up as you do the exercises, and so you're constantly buying replacement parts. But in the simulator, you can do it over and over and over again, and you never tear anything up. So you can get really good without having to invest a lot of money in a physical device. And then we're currently, this isn't even out of the development stage yet. We're working on a video game. The video game also runs online in a web browser, and it tries to teach that team training component that I mentioned before, where you learn to communicate with the members of your team. And since you're working on a keyboard on your laptop in a browser, you really can't expect somebody to learn surgical skills with their hands on a keyboard, but you can expect them to learn communication skills with a team. And there are defined communication skills that have been created by the World Health Organization, and this game essentially encapsulates those into a game format so that it's not as boring as just reading a manual, but it gives you something interactive and more interesting to work with. And so sometimes when you're playing this game, you're looking at your operating room team around the room, like in the upper photo, and sometimes you're looking at the surgical field inside the human's body and being given guidance on what you're supposed to do while you're in there. Now, in the future, we've created all of this material, and we're in the process of doing validation trials on it. We're hoping that it will be adopted one society at a time as the standard by which you train and certify a robotic surgeon, so that when you have a surgeon and they've gone through a course of any kind, anywhere they want, you have some way to test them all at the same level and see if they all have the same skill level before they walk back to their hospital and tell the hospital, I've been trained, I'm ready to be an apprentice, but there's some kind of certification that stands behind that that's more authoritative than just going to even the Nicholson Center and having us stand behind it. We're trying to get it so that it's a curriculum that the societies like the American Neurological Association, the American Association of, forgot what it's gynecologic laparoscopy and several others like that. So it's their home societies stand behind it. So that's what I've got as a presentation. I think we could go to questions and answers if you wanted to try that.
Yeah, thank you, Dr. Smith. Very clear presentation, and those very good slides. Very understandable. Um, so there's no standard of certification right now, formal certification for a surgeon to use a robotics machine in the OR now?
That's correct. No, nothing standard that everybody uses the same thing.
Oh, okay. Well, Gene, I'll start with your questions first. Go ahead.
I was wondering, so you provide kind of like this curriculum right now. What is the acceptance of it around the country and the world in terms of a physician getting one of these?
So the acceptance of it really comes in two forms. An individual teaching hospital could look at this material and say, this meets our needs, and adopt it as their standard. In fact, Florida Hospital is doing that right now for all of our robotic surgeons. But that would make it a very local standard that would apply to a few dozen surgeons that are in your system. The next step up from that would be for a society like the American Urological Association to look at the material and decide that that really meets their needs, and they could recommend it or even enforce it for all of their members. And so then it would trickle down to all the urologists in the country in the case of AUA. Gynecology Society could do the same thing. There's not a national governing body for all robotic surgeons. They're still governed by their individual specialties. So the adoption of this curriculum will happen one specialty at a time. It can't happen to everybody all at the same time.
Do you have any plans to expand this, to have another facility somewhere doing this training?
We do this kind of training here at the Nicholson Center. We have a curriculum. You could come and take what we call the Fundamentals of Robotic Surgery course here. When we did this, getting 60 surgeons to agree to contribute their expertise towards this project required that we make the material that comes out of it public domain. So all of the knowledge about what this training contains is available. It's on the website that I mentioned. So any of our competitors could take that material and build a similar course. And that was our intent at the beginning. We realized that if we tried to own this and treat it as something that only we could provide, that the 60 best surgeons from around the world would not contribute to it. We had to make it something that was good for society as a whole to get them to say, yes, I'm happy to have my expertise rolled in there and see how it can improve training globally.
If you broke it down in percentages, Dr. Smith, what percent are urologists, what percent are OB-GYN, and what percent are general surgeons?
So if you go back a few years, more than half of the surgeons that were performing these 570,000 surgeries a year were urologists. Originally, the Da Vinci robot, when it came out, it really hit a specific sweet spot of need in robotic prostatectomy and in partial nephrectomies, removing parts of the liver. Mm-hmm. So it was the urologists that were doing a lot of the procedures. But then just in the last couple of years, the gynecologists have picked up on it a lot and started using it for hysterectomies. Now, there's a lot more hysterectomies that get done around the country than there are prostatectomies. And so in just a matter of a couple of years, gynecology has gone from maybe a 10% share to a 60 or 70% share. So today there are a lot more GYN procedures done with the robot than there are urology. And it's not because urology has declined, it's just because the use in gynecology has exploded. And then when you follow after that, general surgery, usually something colorectal, and ENT and thoracic surgery are a small fraction. So, you know, altogether 10% or maybe a little more than that.
You know, I had a friend that had a robotic open heart surgery. That was very, very unusual. I was surprised. Do you foresee the day when there'll be a fellowship in robotics in these various specialties?
Yes, there is. So there are fellowships now in minimally invasive surgery, both in urology and gynecology and in ENT. So there are people going into fellowship programs, and when they arrive at that program, they find that that minimally invasive label applies to laparoscopy and robotics. So you're finding that robotics is mixing with laparoscopy inside of existing fellowships. There are a few fellowships that are completely dedicated to robotics, but those are a small number. We have one here because we have a surgeon who does nothing but robotic surgery, and so he runs his fellowship that way. But most of them are still mixing the two.
Okay. You mentioned the importance of teamwork in the OR. Does the team get any kind of training? I know the surgeons go there, but are they given training materials to kind of train their teams when they get home? Because as you know, in the operating room, you depend on the nurses, and they kind of have to know what's going on. Is there any kind of training for them peripherally, or do you give them materials?
There is. There's two kinds of training for the team. You hit on a good point in that there's a lot more funding in the U.S. medical system for surgeons than there are for your operating room team. So you see surgeons running off to training all the time, and they'll taking these special robotics courses that are designed for them. There are also courses designed for the whole team. So to some training centers, you can send the surgeon, a circulating nurse, a bedside nurse, a surgical tech, and they can all, maybe a physician's assistant, they can all come together to the class and take it as a team. Those are available. There aren't a lot of them because most hospitals and most professional credentialing organizations just aren't organized to send people off as a team. This current system is organized to send physicians off to course A, nurses off to course B, and technicians off to course C. And so there's only a few that bring them together. The second way that people get trained is in their own OR. So the surgeon and the company that makes the robot and other hospitals that already have trained operating room teams, they'll come to a new site and train your staff on how to be the team around the robot. And so that gets done on your kind of custom on-site for you.
Now, the funding comes from the hospital and the government, not from Da Vinci or the other big. Mimic is another big company.
Yeah, usually the funding comes from the hospital.
Okay.
If you're going to go off to a class, the hospital has to pay the registration and travel and all those expenses, usually.
Yeah, one comment I'd like to make is that from interacting with doctors all over the world in this platform of Hangouts, and Gene could probably tell you because he goes to foreign countries, most foreign countries look to the United States for training, and then look to, that's the gold standard. Oh, I can go to the United States and do a fellowship or rotation. And is it it must be the same with your center too. What's the breakdown in the attendance as far as countries coming to Nicholson?
Yeah.
Do you have any numbers at all?
So we see people from strong centers across the world, not from every country, but you'll see we have a lot of people that come here from Brazil and Central America. Those are two hot spots. We're in Florida, so it's a very close connection to them. We see people from the European countries, especially especially England and France. And then we see people coming from the Asian countries like Hong Kong, China, but places like that. We have a group coming in a couple of weeks that's a group just from China that is coming, and we're doing a custom program just for a group of Chinese that'll be here for a number of weeks.
You do any remote teaching, like remote from the center to these countries?
So the best we can do, we don't usually, so what we do is we take a course that's happening here, and
right.
It's being put on here. Then we set up our AV so it can be broadcast onto the internet, and they can log into the internet and see it wherever they are.
Okay.
Some of them choose to log in and then broadcast it onto a big screen so that they're like sitting in an auditorium-like room watching it in larger numbers. But we put it out as a stream so that they can pick it up however they like.
So the program's grown pretty much in the last couple of years?
Yeah, it has, especially the broadcasting out. every year the equipment that allows us to broadcast this out gets better and better in quality. It used to be like a single teleconferencing line, video teleconferencing line, and we could have somebody call in and connect to us, and we could broadcast to one site. But now we're getting so that the equipment will let us carry this signal out to a server and then distribute it to as many people as want to subscribe.
Yeah, we televised a conference from Spain using a laptop and an iPhone for the modem. The equipment's getting incredibly powerful.
Yeah.
So things are getting better as far as televising. Any more questions, Gene?
Dr. Smith, have you worked with the Intuitive on this at all? Do they know about this? What are their thoughts?
They do. Yeah, they do. They provided some of the funding for it because they're providing most of the training right now. But when they look at who they are, they recognize that they're in the business of making the robot and supplying the equipment and keeping it running in your OR. By default, that meant that they were the ones who initially knew how to train people to use the equipment. So they got themselves into the training business just so people would know how to use their own equipment. But after a few years, they looked at that and said, you know, that's not really what we're here for. And some of the surgeons don't want to be trained by an Intuitive employee. They want to be trained by other surgeons. So they're helping us make this transition so that this course, the Fundamentals of Robotic Surgery, may come in and supplant the training that's been around for a few years provided by Intuitive.
You know, I think you mentioned a little bit about that you have a connection to Florida Hospital. Typically, do the attendees at your conferences spend some time in the OR of Florida Hospital with live patients?
They do, especially the international ones. Usually when they come to a class and they look at the schedule for the class, they really like to see a live OR visit there. So they'll come and they'll watch videos, or they'll go into our labs and use the robot on some kind of excised tissue. That's all good and great. But they really like to go and sit elbow to elbow with one of our expert surgeons and have him show them what he's doing in urology or gynecology and have him lecture to them why he's doing what he's doing. So yes, we get a lot of that. We also get calls from surgeons around the world that say, I don't want to come to a class, I just want to come and sit in the operating room and watch a couple of your surgeons for several days. And we have the ability to allow that. It's such a small number, though. You can't have 20 people watching every day, but almost every day you walk in, you'll find one of these strangers there who's there to see how it's done.
Very good.
But I wanted to ask you about the simulators. I've never tried one myself, but I was just wondering how close are they to the real deal?
Yeah. So the simulators do a really good job of representing all the mechanical movements of the Da Vinci robot. That part they pretty much got down. It's really well done. The part that simulation as a whole can't tackle is a realistic representation of the human body. The tissue in the human body is flexible, it's profuse with blood, and so if you cut it any place, there's going to be different amounts of bleeding that happen. There are nerves in the tissue, and somewhere not far away there's a heart beating that causes a tremor through the body. And the models that exist of the human tissue are still kind of rough. So most of the simulators have built lots of exercises where you have a model of the Da Vinci robot and it's moving rings around on pegs or dropping jacks into bowls or putting things on rails and little exercises like that that work on the skills you need, but that don't actually represent surgery. There's a couple of the simulator companies are just starting to put out modules that represent a hysterectomy or that represent a prostatectomy, and that do it in a way that you look at it and say, that's pretty close to real. Still rough, but pretty close to real. The medical simulation in that sense of the human body is a long way from what you see in video games where everything looks like photorealistic and amazingly lifelike. It's just not there yet. There's different algorithms that drive how you would animate a human body than the way you would animate a tank or an airplane.
Yeah, I'd like to make one comment in that area. There's been some progress in 3D printing of actual tissue goes in to the body. There's a neurosurgeon from Boston Kids that every time he goes into the brain, he does a 3D model. He has the 3D model of the child's brain made because, as you know, there's anomalous vasculature in many parts of the body, and the surgeon doesn't know what kind of vessel supply he's going to hit. Have you seen any inroads in 3D printing, or is that totally you don't see much of that as far as tissue models?
I would say most of our surgeons are aware of that, and a lot of them have tried it on a once or twice.
Okay.
They don't have a funding model where they can find some way to get that paid for.
Yeah.
So when you do a surgery and you choose to do a 3D print of a body part, that's got to come out of your own pocket.
Okay.
If you can't bill it through to the insurance, you
Right.
might try to bill it directly to the customer, but that would raise their bill.
Right.
So you got to find some way that you can afford to do that.
Right. Yeah, I don't think it's done on a large scale, but I guess in various pockets around the country it's done. But it's exciting, as is the robotics training. And we thank you for coming out today, and thanks Gene for coming out.
Thank you, Dr.
We'll close now, and we'll chat after. So
Thank you.
good day. Good day.
Great talking with you. I appreciate it.
Yeah, thank you. Thank you very much.